My name is Erdenebaatar. I'm from the Kyushu Institute of Technology, and today is our team's idea is the rental satellite for the service for the space education development. And okay, here is contents of today's presentation is introduction, rationale and issues, mission objectives, concept of operations, key performance parameters, implementation, expected results. And here I would like to try to explain today's trend of space technology development throughout world and situation of the education and human resource development. Today, the emergence of new space players is very interesting thing, and here we can see in the 2013, as of 2013, they are already launched the 30 satellites, and from the 27 space emerging countries, and after that time also 38 satellites have been manufactured to be launched. All of these satellites from the emerging countries, I mean the developing countries. So here, the first interest of their country's satellites were the Earth observation satellites. So this is our missions. Why we choose the Earth observation mission to choose our idea. The reason of our idea. So the human resource development education of space engineering is a space engineering program. Approximately the 250 universities and institutions from the 40 countries worldwide, and every single universities try to develop their own satellites and try to launch, and those things they're shown us the increasing of the space technology all the world, and also here we can see the increasing number of the small satellites developed by the universities and institutions, and the estimation shown us from the 2014 to 2020, it will be launched over than 2,000 small satellites from the all universities, and actually not all universities, and I guess probably most of them from universities. And here's issues. Issue is the space debris. Every single satellite will become maybe piece of debris in orbit. And also, on the other hand, the one issue is the satellite development and the launch cost is too high for the developing countries' universities. So, how they solve this problem? And our idea try to solve this problem, and is a rental satellite service. And you can control your rented satellite as you want. So, benefit of our service to provide sustainable, real, practical training for the space engineering course syllabus. It means every university's programs they try to provide the sustainable program to their customers, but for the training practical section is not very sustainable because of the possibility of their satellite usage or satellite. They have satellite or they don't have satellite. It depends on this situation. Also, even they have satellite, but this mission lifetime is not so enough, or maybe for a long time. It's also one issue for the space education, the space engineering program on the universities. And to contribute decrease space debris, we provided this service, and it can decrease the space debris, because I think some of universities just develop, maybe they can develop their engineering model and they can use our service for their practical training. And low cost and fast usage of satellite for users. It means you can use when you want to use the satellite service for education, and you can choose our service. And increase the collaboration between a space developed country and the space emerging countries. It means we guys, the provider, owner of the satellite, this service, maybe would be in the space developed country, and most of users would be the developing countries. So it means that through our service, their collaboration will be increased and become more deeply. And here is our satellite's mission objectives. And as I said, our main mission is the Earth observation mission. And also first is provide the atmospheric measurement data, temperature, pressure, and so on. Second is to provide Earth observation data to end user. It means we plan to use the low resolution camera here. And third, at least 4 times per day to communicate satellites on the equatorial region countries. And it will be increased toward the high latitude countries. These numbers will be increased. And fourth is demonstration of attitude determination control system. We would like to use the attitude control system because this is the give to the users the satisfaction to control their rented satellite, and they can take photo of their university or even maybe their countries, or this is the one kind of the satisfaction of users. And also the fifth one is the users can test their algorithm checking in the orbit. I will explain in next slide. Here is about our inclination is 98 degrees. Because of the possibility of the launch, it's we have the most possibility. And altitude is about 625 kilometer, because of here we can see on this graph altitude and versus the coverage area radius and the distance between the 2 subtracts of the satellites to pass the distance between the 2 subtracts distance. And here for the full coverage of the Earth, for the full coverage of Earth, this blue line is the coverage area radius. Coverage area radius shall be higher than the distance between 2 subtracts on the equatorial region, because it's for the fully coverage Earth. Here, this is the distance between 2 subtracts of the satellite. This is the coverage area's radius, and here this coverage area radius must be higher than this distance. And it means on the equatorial region, every place can communicate at least 4 times per day, and even this small distance they can communicate 3 times, but this distance they can communicate 2 times. Yeah, 2 times means within the 12 hour, and for the 24 hour it can communicate 4 times. And here is the total. We can see the total communication communication time per day. It depends on the latitude. Here we can see, and also here altitude. If the altitude will be increased, the total communication time will be increased, and also the latitude will increase. Also the time will be increased. Here we assume our main ground station is will exist in KIT, and users can use the existing ground station and also the portable ground station provided by the owner. And the communication link will be the VHF link, because it's very popular. And then here, like main ground station control the satellite and monitor the satellite every day, and also the time users can control the satellites. Here is the space segment, and we planned the structure will be the deployable solar panels with this, and size less than this size, and the payload will be the low resolution camera and atmospheric sensors. Simple. And mass and power budget you can see here, and here is the attitude determination control systems, the block diagram. We can see the sensors and the magnetic torque and reaction wheels. Possibility of users. Here we divided the two sections of possibility, and first level is to control satellite and take atmospheric data and to capture images by the low resolution camera. And second level is the algorithm checking on the orbit, OBC algorithm, camera algorithm, ADCS algorithm. It means our satellite contains the two main sections, main subsystem and user section. We can see the orange is the for a user can use these orange sections, and through the communication system they put their algorithm on the user's OBC through the main OBC. They who want to check their data handling or some algorithm on the orbit, they can use this section on the also they can use the control camera payload and ADSS and all sensors. Here is the estimated cost. We can see it here, and here is estimated revenue and benefit. Here is depends on we estimate the total payment of the per month is $35,000, but most of it depends on this launch cost. If we got the launch cheaper launch opportunity, we can decrease this. Here is the project schedule. We assume the 18 months is total time, and expected possibility. A minimum success would be the 5 countries can get the service, and full success is the everywhere from every country can communicate, can take our service, and the extra success is also every country from the world around the world can get our service, and also the some companies if they want to use our service, and maybe they pay money, and also our mission estimated estimated the mission time is 5 years. Okay, here is our team, the new members of Space Family. Thank you very much.
think the user mission is some kind of risk for this satellite. How do you なんていうかな、assure the manage the risk?
Yes, this we assume that the risks the control from main ground station. This is the everyday. It's control the users the everydays the process what they do, what they doing, or what they are doing, and what they testing on the here the every procedure they throw the main OBC, and it means that we can control the mission by the users.
You say the user's mission is under control of main OBC.
Yes, under monitoring.
Monitoring.
Yes.
Okay.
It means they just for the decrease the risk. Yes.
Yeah, I have almost a similar questions. I have almost a similar questions, and my recommendation is that you should make your satellite die hard.
Thank you
Okay.
very much.
So that's a very interesting questions, and so it's a very good technological issue, and so please inquire about that. Okay. And another question is that so if the user want to say do something on your satellite, user can upload their program to the satellite. Is that right?
Yes, it's right. User can completely control the satellite by their existing ground station or the portable ground station to provide to owner, because some developing country, maybe some university has not their own ground station. In this case, they also rent our portable ground station.
Another question is that you will do this for the business?
I am from the Mongolian National University of Mongolia, and for these countries, interest is not business. It's the education.
It's a kind of the how can I say voluntary how can I say contribution to the
Yes,
world. Okay.
yes.
That's good. Okay.
Thank you very much.
If user is going to uplink programs and you are using UHF, VHF, would the speed be sufficient? Or data rates?
We assume the speed is 9.6 kilobit per second. It's we assume quite enough. Yeah, for during this communication time is.
Okay, you had such a study, and okay, and I would suggest how you say low resolution image. What's the resolution you foresee?
We assume the 100 meter per pixel.
100 meter per pixel.
Yes.
Not too bad. And another thing, your orbit is 625 kilometers, and you foresee 5-year lifetime, maybe more. And do you have anything to deorbit the satellite? To deorbit the satellite.
Not yet.
So this should be considered.
Okay. Thank you very much. Thank you. Thank you very much.